Now let's just move on further towards the next important theorem, which do have its own name, which is called as the midpoint theorem. So let's just see what the midpoint theorem says. It says that the line segment joining the midpoints of the two sides of a triangle is parallel to the third side. So let's just prove this particular theorem. First of all, let us suppose if I'm just drawing the figure for this particular theorem, let if I'm taking this triangle as nothing but A, B, C, such that I am taking two midpoints over here, which is nothing but D and F, and I'm joining D and F in such a manner. So let us suppose if I'm just starting with the given condition, given is nothing but a triangle A, B, C and D, F being the midpoints, on the sides A, B and AC, A, B and AC. This is nothing but given to us. So this is the given condition. Now furthermore, what we have to prove over here, we have to prove that the line segment which is joining the two midpoints is actually parallel to BC. So we have to prove that DF, or let us suppose I'm just taking it as nothing but let us suppose it is DF. So we have to prove that DF is nothing but a parallel to BC. We have to prove that DF is nothing but parallel to BC. This is parallel to BC. We have to show this particular fact. Now let us suppose before that I'm just taking a particular construction over here. What is the construction that I am taking? Draw a line segment from C parallel to AB and extend DF to intersect the line segment at E. So what we are doing over here, we are actually doing a little bit of construction in which we are taking a particular line segment which is actually parallel to this AB, So I'm just drawing this particular line segment which is actually parallel to this AB, and I'm just taking I'm just extending this DF over here in such a manner that it is intersecting this particular line segment at the point. Let us suppose if I'm calling it as nothing but E. Now furthermore, let's just start the proof of this particular theorem. So as you can see over here, let us suppose if I'm just talking about this angle and this angle. So since by construction we know that CE is parallel to BA. By construction we know that CE is nothing but parallel to BA. Then DE will exist as a transversal between them, and if it is existing as a transversal, it implies that the angle ADF should be equal to the angle CEF, because they are forming up a pair of alternate interior angles. So if they are forming up a pair of alternate interior angles, then they should be equal to each other. Now furthermore, what can we say about the two triangles? Now furthermore, let us suppose if I'm just taking the two triangles over here. So let us suppose I'm talking about in triangle ADF and triangle CEF. Let us suppose if I'm just talking about these two triangles. So first of all, you can see that we already have proved that ADF is nothing but is equal to CEF from equation number 1. Let us suppose if I'm taking it as 1. So we have already proven this particular fact that these angles are equal to each other. Furthermore, we know that angle AFD is also equal to the angle CFE, because they are forming up a pair of vertically opposite angles. So they are equal to each other. Means this angle is equal to this angle. Furthermore, we know that AF is equal to FC. Since we know that F is the midpoint, so this side should be equal to this side, this side should be equal to this side. So what can we say about these two triangles? So obviously by these three conditions, we are getting triangle ADF is congruent to the triangle CEF by AAS congruence criteria. By angle side congruence criteria, we can say that these two triangles are congruent to each other, and if they are congruent to each other, it implies that AD should be is equal to CE by CPCT. Let us suppose if I am calling it as equation number 2. Now furthermore, since we know that AB is actually parallel to CE, we can also say that BD is also parallel to CE. Since BD is nothing but half of AB. So if AB is parallel to CE, then we can say that BD is also parallel to CE. So let us suppose if I am calling it as the third equation. So from 2 and 3, we can say that from 2 and 3, one pair of BDEC is parallel and it is also coming out to be equal, because it is parallel. We can say that from 2 and 3, one pair of BDEC is parallel and equal as well. How it is equal? It is equal as well. So we can see over here that we definitely know that AD is nothing but is equal to CE from the equation number 2, and we know that AD is also nothing but is equal to BD. Why so? Because we know that D is nothing but the midpoint, so this side is also equal to this side. So hence, if these are equal to each other, it definitely implies CE. It definitely implies CE is equal to BD. So hence, if BD is parallel to CE and BD is equal to CE, it implies that BDEC is a parallelogram. And if it is a parallelogram, then it implies that DE is parallel to BC. Since the opposite sides of the parallelogram, are parallel in a parallelogram, so DE is parallel to BC, which implies that DF is also parallel to BC, because you can see that DF is nothing but a part of DE. If whole DE is parallel to BC, then DF is also parallel to BC, and this is exactly what we have to prove over here, that DF is actually parallel to BC. So hence proved this theorem. This is nothing but the proof of this theorem, in which we have proved that the line segment joining the midpoints of the two sides of a triangle is parallel to the third side. This is nothing but called as the midpoint theorem.